Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve a linear static analysis of a cube using Code Aster. So our problem is we'll be going to apply a compression force of a cube a size of 1 meter into 1 meter into 1 meter, and the material property is I've taken as a steel. Young's modulus is 210 gigapascal and Poisson ratio is 0.3. So this is my model. So I'm going to create this model using Salome, and using a mesh model I'm going to create a mesh of external element. So this is the pressure I'm going to apply, 1 into 10 power 6 Newton per meter square. So bottom face I'm going to fix it. So this is a displacement plot and 1 meter stress plot. This is the displacement plot and this is 1 meter stress plot. So this is the deformed shape of our model after applying the force. Let's get started to solve the problem using Salome meca. So first just go where your file you kept. So I have kept my file here, Salome meca 2022. So this is the file I'm going to open. So just open the terminal here and just open it by using this command. Just wait for a while, it will get open. This is Salome meca. It has different models for different applications. In this finite element analysis we are going to use only geometry model, mesh model and Code Aster, which is the solver to solve the finite element model. Then Paravis is the post-processing tool to view the results. Okay, so first I'm going to go for geometry model. Now just go to the problem. So our geometry is just a simple cube of 1 meter into 1 meter into 1 meter. So for this we can directly take a cube which is already available, create a cube, just specify the length. So this is 1 meter, 1 and 1. Salome doesn't have any unit consistent, so whatever the unit you are taking, the same unit has to be followed. So 1 means while applying a material property you need to apply in meter. If you are taking as a, this is a 1 is meter. Okay, so apply and close. Just click this fit screen. So we have created this model. So you can rotate by using this rotate icon. So now what we want to do is we just want to create a groups for applying the boundary conditions. So go for create group, face group, because so the bottom face I want to fix it. So select this bottom face, add, just name it as a fix and apply. Now the second face is this one. Here I just want to apply a pressure of 1 megapascal. Pressure, apply and close. See here, this is a box, the volume boundary, the fix is the bottom and pressure is the top. Okay, now we have created the geometry. Now we just save this file. Go to file, save as. Now I'm doing in pictures, Code Aster, static analysis. I'm just saving here. So after saving it, you just go for meshing. So mesh. Now we are in the mesh model. Just select this box. This is our model. Go for mesh, create mesh. So now there are different algorithms that to create the mesh here. So now we are going to use hexagonal element to generate mesh. So hexagon. 2D has to be a quadrangle mapping. 1D is a wire discretization. Just change here. You just go click this gear button. There are different algorithms there to specify the to divide the wire. So I'm going to use local length of it shows the default length size of 0.173205. Now I'm just going to change this into 0.05. just OK, apply and close. Now just right click this mesh one and go for compute. Now you can see here it has generated a hexagonal element. Here you can see there are 8000 hexagonal elements and quadrangle element 2400 quadrangle elements. So and edge is divided into 240. So just close. If you want to make pyramid element, prism element, or tetrahedron element, there are different algorithm has to be used. So this is the mesh information we have. Just close. Now you can see here we have taken this groups also here. There are fixed boundary condition, pressure boundary condition. We have taken these groups into the mesh also. Now we are going to use this mesh for solving the problem. Okay, I'm just saving this again. Now we need to go for solver. Our solver is Code Aster. Just go to Code Aster. So choose Code Aster version. Here we can choose the stable or testing version. Now I'm going to use stable version. Just OK. So now we are in the Code Aster module. First we can separately do these things: creating mesh, model, material, function and list, boundary condition, everything. And in one more thing is Code Aster itself has assistant. Add a stage with assistant. Ours is a linear static analysis, which is very simple analysis. So for that it has assistant to use it. So isotropic linear elastic assistant, you can use this. So I'm going to use this isotropic linear elastic assistant. So just click this one. By using this wizard we can do only 2D and 3D mesh. We cannot do with only 1D mesh, and we can apply only two boundary condition. One is blocked displacement boundary condition, another one is pressure boundary condition. So as our problem is applying the same thing, so I'm going to use this wizard to apply the boundary conditions. So go to next mesh. It has taken the mesh. Next, ours is a 3D one. If you want to use other one, we can choose C-plan, D-plan and axis symmetric models. Ours is a 3D one. So 3D, go to next. So our Young's modulus is 210 gigapascal. So same thing is there, and Poisson ratio is 0.3. You can check with here. So 210 gigapascal and Poisson ratio is 0.3. Now just go to next. So now I just want to apply boundary conditions. Just add here. Just click this button to add the boundary condition. Edit. Choose the boundary condition as a fix. Just OK. Enter the value of 0 to fix the 3 directions. Then go to next. Again add here. Here I am going to apply pressure. Choose the pressure group. Here our pressure value is 1 e power 6. What it will apply is, it will apply normal to the surface. For example, just go to the model. This normal to the surface it will apply. If you want to pull it, we just want to apply it as a negative value, but in our case we just want to compress it. So I'm just giving as a value of 1 e power 6 as positive. So now just go to next. Now we just want to save the output file. Just go to browse, Vengat. Here just go to here as a pictures, Code Aster, static analysis. Here just name it as static underscore result dot RMAD. Just save. So RMAD is the output file format. So this is the way we just want to write. Just go for finish. Now you can see it has generated everything. So first mesh, defining the mesh, then defining the model definition. From the mesh, so it has used layer mileage to define the mesh, Then model definition, model, just go for model, FEA model, it has defined the model. Then material, first we need to define the material, then we just want to assign the material. So for define the material, so it has used defi material, so then assign the material, we need to assign the material for assign material. Then boundary conditions, so there is no functions here we are used for boundary condition. So for here a feature meca is used, so fixed boundary condition and forced boundary condition. Then analysis, for analysis ours is a static analysis, so meca static we have used. Then output, so it will only show the displacement. If you want to get stress and other thing, we just want to calculate the one meter stresses and directional stresses from the displacement. So for that we just go for post processing, camp. So we need to add this one into same value result and go for constraint. Just check with sigma elemental directional stresses and sigma is a directional stresses, sigma xx, sigma yy, sigma zz. Sigma xy z, this will calculate that directional stresses, it will calculate. Then if you want to get elastic strain, plastic strain, everything, we can go for deformation. If you want to calculate energies, we can go for energy. Now we just want to calculate one meter stresses, stresses, everything. For that we need to go for criteria. Here just choose the equivalent stresses, so equivalent element and equivalent node. These two things we just want to calculate. Okay, now we have just go to apply, just OK. Now we have calculated the values. After calculating, we just want to export the value into IMPR ratio. So just double click this one. Here we just want to add it. For that just go for namcham. Here we just want to specify it. So first thing is displacement, second one is sigma, this one, and SIGM underscore NOU. Here this one. These three things we just want to calculate it. Okay, then just round this one. So there is one more option, is called tout OUI. That means that we just want to calculate to all. Then just give OK. Then again you just give OK. Now you can see displacement, equivalent stress and normal stress. This all thing we just want to take it as output. So now we have done our setup. Then we just go for solving it. So just save this file. I have saved it. Just go for history. So here just press this plus button, plus, then this is keep result. Just click this one. Now here we just want to run it. To view a message file, just go auto refresh into 5 seconds. Just run it. Here the message file will open. If any error comes, we can see it here. So now it's reading the input file one by one and executing it. Now it's solving. So now you can see here the case is completed without any error. Here also you can see it as the diagnostic job is okay and the outputs are saved. If you want to open any output files, you can go for message. So this is the message file. Everything is written in French. So if you want to understand any message, you just copy and paste it in the Google translator and get it. So now, so results are done and saved. Now we can go for post processing. Just go for Paravis and you just click this built-in and right click it and open. Go to pictures, Code Aster, static analysis. Here the result file is saved, static underscore result dot rmd. Just select this file and OK. Just apply it. Now you can see this is the results: displacement, equivalent stress and normal stress. Now you just go change into displacement, and this is a displacement magnitude. So just keep this into here, change into white background. For that, just click into white background, and we can change this color pattern into blue to red. So rainbow, blue to red, apply, close. Similarly, just drag it down here. Here number of values into 12. Just enter it. This is the displacement plot. And if you want to get it von Mises stresses, go for SIEQ no. So these are different stresses you can see here. I want to take von Mises stresses. Similarly, here just change the color pattern to rainbow, blue to red, apply, close. And number of color value is 12. Just enter it. Here you can compare the stress. Normally the area, whatever the pressure we are applying, the same value we just want to get it. You can see at the fixed boundary condition, yes, stresses is going high because of we are constraining every nodes. Just check the results outside the boundary condition. Here the stress value is around 1 e power 6 Newton per meter square. So the stress value is what we are applying, the same only we are getting. So pressure and stress both are in the same unit. So the value is 1 e power 6. So our results are correct. Similarly, you can go for sigma directional stresses. So here we can check Z. So similarly, you just go here, change this into rainbow, blue to red, apply and close. This one is 12. Here also you can check the result of sigma. We are compressing it, that's why the directional stress coming minus 1 e power 6. Here you can see this red is minus 1 e power 6. If you want to check the results by points, you can go for a value of node value. Here you can see this is the way we can check the results. Now, so we have completed this analysis. Now we just want to see the deformation of the body. So for that, just go for displacement, magnitude. Here there is one more option is called wrap by vector. You just click this wrap by vector. Here there is one more option is called as scale vector. You just make into mid, then apply it. So this is the way it will get deformed, but our deformation is very less, but we are just just enlarging the deformation to scaling. We are just scaling the deformation. To simulate this one, you just right click this animation. Here there is a play button. Just create a new animation track. Just same thing one. Just apply it. So now we can animate it. So just cycle it the plate. This way we can animate. So just stop it. I'm just stopping it. So thank you for watching my videos. Please subscribe my channel for more videos, so it will encourage me to put more videos about Code Aster and Salome. So thank you.